Good morning to everyone. This is Raghavendra from Data Science Department, working as Assistant Professor in Marri Laxman Reddy Institute of Technology and Management. Today we are discussing about discrete mathematics. In this discrete mathematics, major key points are mathematical logics and set theories and permutations and combinations, recurrence relations and graph theory. Like these are the major key concepts in the discrete mathematics concept. First of all, what is discrete mathematics? Why study the discrete mathematics? What are the main uses and which will need help to discrete mathematics? So, discrete mathematics is a branch of mathematics. It deals with the discrete elements, okay, that uses the distinct values. Unlike calculus, algebra, it deals with the continuous functions and real numbers. Here, discrete mathematics focus on the structures like graphs, trace, statements in logics, set theory, relations and functions, permutations and combinations. These types of concepts mainly focused in the discrete mathematics concept. What is the helps in the discrete mathematics? Major students are most useful in the discrete mathematics are it helps in the problem solving, enhancing reasoning and analytical thinking, and support data structure and algorithms like trees, graphs, hash functions, hash tables, etc. And fundamental to computer science like mathematical logic, set theory, algorithms and graph theory are essential in programming, database and software development program. So this is the discrete mathematics is the core subject in the computer science of students like data science students and computer science of engineering students. Next we will discuss about the major key points in the discrete mathematics. So first, set theory. So set theory is the one of the key topic in the discrete mathematics. This is the covered in the all study of sets, collection of objects, operations and relations. Mostly covered into the set theory concept. Next, logic and propositional calculus. Here, analyzing the truth values of the statements using logic gates and Boolean values. Some truth values, truth tables, these are the analyzing the statements by using the logical gates. Okay. Next, relations and functions. It is describing the mapping and association between the sets. Next, combinations. Continuing methods, permutations and combinations used in the probability and analysis. Here is this concept. And next, graph theory. Graph theory is the study of graphs like nodes and edges, paths, circuits, trees, like virtual networking and algorithms. Next, mathematical induction and recursion. Here, providing the values and defining problem using self-references methods. So these are the main key topics in the discrete mathematics concept. Set theory and logical and propositional calculation, relations, functions, combinations, graph theory and mathematical inductions. These are the mainly key topics. Here we will discussing about the first chapter, mathematical logic concept. So mathematical logic concepts are like first concept is the basic concept is the propositions. So what is proposition? Proposition is a declarative sentence. Here, proposition. Proposition is a declarative statement which is either true statement or false statement, but not for the both. This is known as the proposition statement. Next one, compound proposition. Compound proposition is the mainly when one or more connectivity statements, various one or more connectivities like statements, compound propositions, when one or more statements will when one or more propositions are connected through the various connectivities is known as compound proposition. Okay, so we'll see some examples. Proposition. So proposition is a declarative sentence which is either true statement or false statement, but not for the both statement, is called the proposition. So proposition can be represented by small letters like any, P, Q, R, S, and so on. Okay, so you can see the example here. One statement, 2 plus 2 equals to 4. So this condition is true. So it is a proposition statement. Next example, the sun rises in the east. So this statement, this condition is true. So it is a proposition statement. And next example, B is a oval. So this condition is false, but it is also a proposition statement. Why? Which is either any true statement or false statement. Okay, so that's why you call the proposition statement. Next, compound statement. Compound statements, when one or more propositions are connected through the various connectivities, is known as the compound proposition. For example, P statement, 2 plus 2 equals to 4. So this is one statement, and Q, 2 is a prime number. This is one statement. These two statements connected through connectivities. Okay, so here 2 plus 2 equals to 4 and 2 is a prime number. Here and is the connectivity. Okay, and here 2 plus 2 equals to 4. R is the one of the connectivity and 2 is the prime number. So here two proposition statements connected with connectivities. Okay, so that is called the compound proposition. And we will take one more example. P is sun rises in the east. So sun sets in the west. Here taking one more example. Here we are using the one more connectivity like sun rises in the east and sun sets in the west. Here also using the one connectivity, and next example, sun rises in the east or sun sets in the west. Here we are using the one more connectivity. So one or more statements connected through the various connectivities is known as the compound proposition. And next types of connectivities. Next concept. Here we have different types of connectivities. First one is the and connectivity, and disjunction connectivity, and condition connectivity, and bicondition connectivity, and negation connectivity. So here types of connectivities and and, or, if, then, if and only if, and not. In terminology wise, we are called the conjunction, and is called the conjunction, and disjunction, and implication, and by implication, and negation. So we'll go through the one by one. Next, first one, conjunction. Here, let P and Q be a proposition. The conjunction of P and Q can be written as P and Q. Logically term wise, we are calling the conjunction. Okay, it can be written as a P and Q. Okay, the statement of P and Q is true. The statement of P and Q is true when both P and Q is true. Otherwise, remaining all cases, it will be false. The statement of P and Q is true. Okay, both P and Q are true. Both P and Q are true. So P and Q statement is true. Remaining all cases, it will be false. Okay. Next, disjunction. Disjunction. Let P and Q be a proposition statement. The disjunction of P and Q can be written as P or Q. Logically, we will call it as disjunction. Okay. So the statement of P or Q is false. Logically, P or Q is false when both P and Q is false. So both P and Q is false. So the statement of P or Q is false. Remaining all cases, so true. The statement of P and Q is when false, the both P and Q is false. Remaining all cases, it will be true. This is called disjunction. Next statement, conditional statement. Conditional. Let P and Q be a proposition statements. The condition of P and Q can be written as P implies Q. Okay. Logically, we call it as conditional or implication. It can be written as P implies Q. Okay. Here, P implies Q is false. When P implies Q statement is false when P is true and Q is false. Remaining all cases, it is true. P and Q statement is false when P is true and Q is false. Okay. Remaining all cases, it is true. This is called implication statement. Okay. Next, by implication. Let P and Q be a proposition. The by conditional of P and Q can be written as P by implies Q. Logically, we call it as by conditional or by implication. Okay. The P by implies Q condition is true when both cases are the same. When both cases are same, though P by implies Q is true. Remaining all cases, it is false. Both cases are same. Okay. Otherwise, false. This is called biconditional statement. Next, negation statement. So let P be a proposition. The negation of P can be written as negation P. If P is the true, then negation P is the false. If P is the false, then negation P is true. So Here P statement, P is the true, negation P is false. If P is false, negation P is true. This is called negation statement. Next one, tautology. Tautology. If the last column of the truth table, all cases are true, then it is said to be a tautology. The tautology is also known as universally valid statement. So here the example of the last column of the truth table, all cases it is true. So then it is said to be a tautology. So all cases, last column of the truth table, all are true. Okay, this type of scenario we will call the tautology. Next one, contradiction. The last column of the truth table, all are the false, then it's said to be a contradiction. Contradiction is also known as falsity. Here the last column of the truth table, all values, all cases will be a false, then it's said to be a contradiction. So this is called contradiction. And next one, contingency. The last column of the truth table, some truth values are true and some truth values are false, then it's said to be a contingency. So contingency. Here the example of last column of the truth table, some truth values are true, some values are false. So this is the contingency. Last column of the truth table and some truth values are true and some truth values are false. This is called contingency. Thank you.